All right. Now, first of all, we need to understand in partial fractions what this term actually means. Partial fractions. Let's take an example. Let's start with an example. Let's say we've got something like this. 4 over x plus 2 plus, let's say, 7 over 2x minus 4. Okay, I've got these two fractions and I'm adding both of them like this. Now, how do I make this one single fraction? What's the process that we follow for that? We take LCM, right? How do you take LCM here? You used to multiply this denominator with this numerator and this denominator with this numerator. And that is going to give you 4 times 2x minus 4 plus 7 times x plus 2 in the numerator. And in the denominator, you've got x plus 2 into 2x minus 4. All right. Now let's simplify this. This gives us 8x minus 16 plus 7x plus 14 whole divided by x plus 2 into 2x minus 4. Let's not simplify the denominator for now. We'll figure out later why. Let's just simplify this. What do we get from this now? 8 plus 7, that is 15 times x, minus 2 divided by x plus 2 into 2x minus 4. So we started with these two fractions and we were adding those two fractions. When we added them, we got a single fraction from that. Okay, you taking LCM, we got a single fraction. All right, so all of you are familiar with this process. You know how to take LCM and convert multiple fractions into one single fraction. All of you know how to do this. Now, what are partial fractions? Let's say we had this fraction given, and from this fraction, we wanted to go back to these two parts of this fraction. This process would be called finding partial fractions, and these are the partial fractions of this thing. All right. Now, let me write that down. If you were to go back from this single fraction to those two separate fractions, this is part 1, right? And this is part 2. And both of them together, they're known as partial fractions. So you can understand partial fractions as the opposite process to taking LCM. All right. If you have a single fraction given, you want to convert it to two separate fractions. That is what you're trying to do here. Okay. Now let's see how this process works, how we find these partial fractions. So now we want to start from this fraction, 15x minus 2 divided by this. We want to find the two parts that make this fraction up. So we've got 15x minus 2 divided by x plus 2 into 2x minus 4. This is what the fraction is. Okay. Now we want to split this fraction into its parts. How do we start with this? Now, it's really easy to figure out the denominators first, right? So remember what we did here? We just multiplied the denominators to get this LCM, right? So you've got the two factors in the denominator already. So if you were to split this fraction, you would know that the first fraction should have the denominator x plus 2, and the second one should have 2x minus 4. So figuring out the denominator is not going to be that complicated. Okay, we'll have some cases, some different cases for this. We'll find them out. We'll talk about them later. But denominators are generally going to be easier to figure out. Okay, you don't have to do any calculation for that. You can just write them down directly. The problem is going to be numerators. how do we know what is going to be here and how do we know what's going to be here? That's the problem. Now for that, what we do is we denote these numerators with some letters. We say this is A and this is B, let's say. So now the problem is reduced to finding the values of this number A and this number B. If we can find A and B somehow, we would know what the partial fractions are going to look like. All right. Now, how does this process work? Now, before we try and get into this, I want you to understand what identities are. Okay, let me just check if we've talked about that before. Modulus, polynomials. Have we talked about identities before or have we not? Can you remind me? Have we talked about identities in this class? I think we haven't. Okay, let me just explain that on this side here. So basically, there's a terminology that we use that two expressions are identical to each other. And we also have equations. If I have something like this, for instance, 2x minus 6, and I have 2 into x minus 3. Now think about these two expressions. Is there any difference between them? There's no difference. They're exactly the same expression. They're just written in different ways. Okay. This thing and this thing, they're exactly the same. It's just that I've taken 2 common here. We say these two expressions are identical to each other, and this is the sign that we use for that. And the sign means that the left-hand side and the right-hand side, they're identical to each other. So this is an identity. Now, what's special about identities? Identities are true for all values of x. All values of whatever the variable is, in this case, the variable is x. They're true for all values of x. So basically, if you were to input any value of x on the left side and put that same value of x on the right side, the left-hand side would be equal to the right-hand side, no matter what value of x you input. So they're always equal. So they're true for all values of x. The left-hand side and the right-hand side, they're always equal, no matter what value of x you input there. Now that's different from equations, because equations are only true for some specific values. So for instance, if I had an equation like this, 2x minus 6 equals, let's say 4, then this equation is only true when x equals 5. Otherwise, this equation is not true. Okay. So similarly, I could have a quadratic equation. Let's say x plus 2 into x minus 3 equals 0. It's a quadratic equation. This equation is only true when x equals minus 2 or x equals 3. Equations are only true for some specific values of x. These are equations. They're only true for some specific values of x. They're not always true. Okay. They're only true for some specific values. Now, keeping this in mind, what identities are, they're true for all values of x. If you go back here, we've got this fraction. We want to split it up into its 2 parts. This is essentially exactly the same expression, just written in a different way. So the left-hand side here and the right-hand side here, they are identical to each other. Okay, that means they're going to be true for all values of x. No matter what value of x we input here, they're always going to be true. Okay, now this is going to be important because now we will be using this idea to find the values of A and B. All right. Now, let's start with this process. How do we figure out the values of A and B from this? How do we start? Now, the first thing we do after this is, after we've written this fraction into its parts like this, what we do is we multiply this denominator on the left side on to the right side. We multiply this denominator on the other side. Okay. Now, what happens if we do that? We get 15x minus 2 here on the left side. But what about the right side? When this thing gets multiplied with the first fraction here, we have x plus 2 into 2x minus 4. X plus 2 and x plus 2, they get cancelled. What are we left with? We're left with a times 2x minus 4. Similarly, we multiply this denominator with the second fraction as well. When that happens, we have x plus 2 into 2x minus 4 multiplied with this b. And now 2x minus 4 and 2x minus 4 get cancelled, and we're left with x plus 2 there. Right? So we have plus b into x minus 2, plus b into x plus 2. So we have converted that form to this form now. All right. Now, once we're done with this, now we need to find the values of a and b. So this is something that you're always going to need to do. After this point, there are two methods for this. I will generally be using one particular method, but I'll tell you the other one right now as well, and then it's your choice. But I personally find the first method to be easier, which I'm just going to start with right now. So the first idea would be that we input some specific values of x in this identity and use them to find the values of a and b. So remember what I said here. An identity is something that's true for all values of x. So we could actually input any value of x in this expression that we want, and the left-hand side would be equal to the right-hand side. Okay. So what we do is we input some specific values of x in this identity, and that is going to give us an equation in terms of a and b, and we can solve those equations to find the values of a and b. All right. But we can try to be a bit smart here. How? We can input values that would eliminate one of these variables at least, so that we don't have to solve simultaneous equations. We can just find the values of a and b directly. How would that work? You're going to think about these brackets. And you're going to think about the values of x that would make these brackets equal to 0. For instance, this is x plus 2. How do I make this 0? X plus 2 equal to 0. When is that possible? When the value of x is minus 2. So what I do here is I say, let's input x equals minus 2 in this identity. Remember, it has to be true for all values of x, so we can input any value of x that we want. So this is a value that we start from, x equals minus 2. Now, why is that helpful? Because on the left side, it's going to give us 15 into minus 2 minus 2, but on the right side, you would have a into 2 into minus 2 minus 4 plus b into minus 2 plus 2. And this thing is going to become 0. When that becomes 0, b gets eliminated, and we're just left with minus 30 minus 2, which is minus 32 on the left side. On the right side, we've got a into minus 4 minus 4, which is minus 8. Divide minus 8 on the other side now, and that gives us a equal to 4. We find the value of a from that. So we got rid of the variable, this letter b by making this whole bracket 0. And now we have only a left. We can find the value of a from there. Now, once we're done with this, we can think of the other bracket. How can we make this 0? Again, put this equal to 0. 2x minus 4 equals 0. When is that true? When x equals 2. So that could be another value of x that you input here. You input x equals 2 and see what that gives you. So again, in that expression that we have in the top, we input x equals 2. 15 times 2 minus 2, that equals a into 2 times 2 minus 4. And you see this whole thing becomes 0. This whole thing becomes 0. And then we have plus b times x plus 2. That is b into 2 plus 2. All right, let's simplify this now. We've got 30 minus 2, which is 28, equals 0. This whole thing becomes 0. How is that helpful? Because a gets eliminated now, and we have 4b left. We can find the value of b from this. B turns out to be 7. This is the value of b that we've got now. So we find the values of the two unknowns, a and b. We've got them now. We just input them back in these partial fractions, and we can say these are the partial fractions that we were looking for. In place of a, we can input 4. And in place of b, we can input 7. And if you remember, this is exactly what we started from. We had these two fractions, 4 over x plus 2 plus 7 over 2x minus 4. We took LCM and we got to this. And now using this partial fractions process, we got those two fractions back, 4 over x plus 2 and 7 over 2x minus 4. So this is how you can find partial fractions of a fraction. All right. Does this make sense to everyone? Any questions on this? Any problems? No? All right, so this is the method that we are going to be using in all the questions that we do. There's also another method that exists. I'm just going to let you know about that. Then we end today's class, but I will be using this method for all the problems that we do because I find this a lot easier than the other one because the other one gets complicated in some scenarios. So I would not recommend that, but it's your choice, of course. At the end, you can, both are correct. You can use whichever of them you want. Now, what's the other idea? This is how it looks like. So until this point, where you have these two fractions, and you have gotten to this step, it's exactly the same. There's nothing new until this point. So let's start from this. We've got 15 x minus 2. That's identical to a into 2x minus 4 plus b into x plus 2. Okay, this is what we have. Until this point, it's all the same. But after this, in the first method, we were inputting some specific values of x here. All right. Rather than that, another idea could have been that we just simplify the right-hand side and see what that gives us. Simplify the right-hand side. Now let's do that here. We've got 15x minus 2. That's identical to 2ax minus 4a plus bx plus 2 times b. And now what you do is you bring the x terms together and the constants together. Constants are all the terms that do not have x in them. And see what that gives you. 15x minus 2, that is identical to 2ax plus bx minus 4a plus 2b. All right. So we've written the x terms together and the constants together. Now you take x common from the x terms and keep the constants together. What does that give you? 2a plus b whole times x minus 4a plus 2b. On the left side, you've got 15x minus 2. Now, remember the left-hand side and the right side, they are identical to each other. That means they're just different forms of writing the same thing. So that means whatever is the coefficient of x on the left side should be equal to the coefficient of x on the right side. And whatever is the constant term on the left side, that should be equal to the constant term on the right side. And that gives us two equations. So we've got 2a plus b equals 15. And we have minus 4a plus 2b, that equals minus 2. All right. So we equate the x coefficients and we also equate the constants. And now we've got two simultaneous equations. We solve them simultaneously, find the values of a and b from them. Let's make b the subject here. That gives us 15 minus 2a. From the other equation, we've got minus 2a plus b equals minus 1. If I divide the whole equation by 2 to simplify this, and then I can write it as b equals 2a minus 1. I've got b as the subject in both those equations, so I can just equate both of them, and that gives us 15 minus 2a equals 2a minus 1. Take all the a terms to one side, that gives us 4a equals 16 and a equals 4. Now put this back in any one of those two equations, and that's going to give you the value for b. b equals 15 minus 2 times 4, and that equals 7. And again, we've got the same two values of a and b. A equals 4 and b equals 7. So this is another method for finding partial fractions. You can find those values of a and b by simplifying both sides and then comparing the coefficients of the like terms. Now, this was relatively straightforward in this particular example, but still you had to solve two simultaneous equations. This is not the only form of partial fractions, however. You get some more complications. And in those types of questions, you end up having to solve a set of equations simultaneously. And sometimes there are more than two. So you have 3 variables and 3 equations, and that starts getting a bit too complicated pretty quickly. Okay. But it works eventually. But in my opinion, in my experience, it is mostly going to take longer as compared to this first method that we did. Okay. So I've told you about both of them. If you want, you can use this one as well. But I would prefer this first method in which we input some specific values of x and eliminate some variables and find the values of the constants using that. Sometimes you would not be able to eliminate variables. In that case, you will be inputting some easy values of x, like x equals 0, x equals 1, and then solve simultaneous equations, but it's still not going to take as long as it would take in the other method. But you'll find out about all of this in the next session, inshallah, when we discuss some more examples. We actually have 3 different forms of partial fractions, which we will talk about tomorrow, inshallah. For today, this is the important bit, that you need to know how to find partial fractions using this method by inputting some specific values of x on both sides of this identity. If you have any problems in this, let me know. Otherwise, that's it for today. And I'll see you again tomorrow, inshallah. If you have any questions, you can ask right now.